NQA can be associated with static routes to monitor their link status. If a link fails, an NQA test instance rapidly detects the failure and instructs the routing management module to delete the static route associated with the instance from the IP routing table. Traffic is then forwarded along another link, preventing lengthy service interruptions. This video provides an example showing how to configure association between static routes and NQA. On this network, device A establishes neighbor relationships with device B and device C. Static routes destined for the user are configured on device B and device C. Device B is on the primary link, which is link A, and device C is on the backup link, which is link B. It is required that service traffic be transmitted over link A in normal cases, and quickly switched to link B if link A fails. Association between static routes and NQA can be configured as long as one of the two communicating devices supports NQA. The configuration process consists of 5 steps. The following describes the configuration process of each step in detail. Step 1. Configure IP addresses and mask lengths for G100 and G101 on device A, device B, and device C. Step 2. Create an ICMP NQA test instance with the destination address being 172.16.1.2 between device B, the NQA client, and switch A, tested device, and configure key parameters for the NQA test instance to detect faults on the primary link between device B and switch A. The device allows multiple key parameters to be configured for an NQA test instance. You can select the parameters as required, and the settings of the parameters must meet the overall requirement. Step 3. Configure a static route to 172.16.7.0 on device B and device C, and associate the static route with an NQA test instance on device B. When the NQA test instance detects a link fault, it instructs the routing management module to delete the static route from the IP routing table. Step 4. Configure a routing protocol on device A, device B, and device C so that they can learn routes from each other. To facilitate verification and explanation, OSPF is used as an example in this video. You can select a routing protocol based on the actual networking. Step 5. Configure OSPF on device B and device C to import static routes, and set the cost to 10 and 20 for the static routes on device B and device C, respectively. When device A learns routes to the same destination from device B and device C, it preferentially selects the one with a smaller cost, that is, the one along link A. After completing the configuration, we can view the NQA test state using the display NQA results command. The NQA test state can be success, no result, or failed. Success indicates that the NQA test is successful and that the static route remains active. No result indicates that the NQA test is in progress and that the original status of the static route is not changed. Failed indicates that the NQA test instance fails and that the device instructs the routing management module to delete the static route associated with the NQA test instance from the IP routing table. Now, let's check the NQA test state on device B. We can see that success is displayed in the command output. It indicates that the link is normal, the static route remains active, and that service traffic is transmitted over link A. Then let's check the routing table of device A. We can see that the next hop from device A to switch A is device B, indicating that the traffic destined for the user is transmitted over link A. To verify that association between static routes and NQA takes effect, we can manually shut down G101 on device B to simulate a fault on the segment between device B and switch A on link A. Let's check the NQA test state on device B again. We can see that failed is displayed in the command output. It indicates that a fault occurs on link A. In this case, the static route associated with the NQA test instance is withdrawn. Let's check the routing table of device A again. We can see that the next hop from device A to switch A is device C, indicating that the traffic destined for the user is transmitted over link B. It proves that the association between static routes and NQA allows service traffic to be rapidly switched to the backup link if a fault occurs on the primary link. That's all for this video about how to configure association between static routes and NQA on a NetEngine series router. Thank you for watching.